so experiment 7, y'all. So look on this sheet here, and we're gonna walk through this sheet here and answer these. All right, so experiment 7, what happened, y'all? Stay for this whole video. It's gonna be 10 minutes, but it's gonna be helpful. It won't waste your time. You're gonna learn it. Okay, so what we did in experiment 7, if you remember, and if this is blurry, just listen along. We added silver ion, lead ion, and copper ion into a centrifuge, and we also added unknown solution of ions into another centrifuge. And the point was to determine which of these silver, lead, or copper ions are in the unknown solution. And we used the known solution to compare. But let's just focus on the known solution right here. So first step was we added the 3 ions into the centrifuge. And then by using selective precipitation and then decanting or pouring off part of it, we could separate and find out, separate these ions. So we pour them into the centrifuge, and then we add drops of 6 molar HCl, hydrogen chloride, added it. Now what happens with that? Well, there's these reactions that happen. First reaction is Ag plus. Well, Ag plus the chloride goes to Ag chloride. It's a solid. It changes to a solid. Same with the lead plus the chloride goes to the lead chloride solid. But then the copper and the chloride do not react together. There's no change. It's still an ion. So now what we do is we stir the mixture, and then we should see a white precipitate, which is the bottom. This is the precipitate. It should be white, forming onto the tube. And then what we do is we're gonna place the tube into the centrifuge and centrifuge it, okay? So you should see the white precipitate at the bottom, which is the solids, Ag and PbCl. And then you see the copper is just on top of that, called the supernatant. Now we're gonna spin it around, mix it up good, and then the solid's gonna be sitting on the bottom and the Cu is gonna be on the top, and we just pour it off, decanting it. This is all found on page like 51 of the manual. Okay, so now the copper is all gonna be poured off, and it's been separated. So now you have a test tube. We have poured this tube into a test tube, and we only have copper in here now. Now, we think we have copper. We know we have copper in the known. We don't know about the unknown. But we're gonna do a test on the known to see what copper looks like. So we have our copper, 2+ ions all in here in this test tube. And we still have our regular tube with the Ag and Pb at the bottom connected with the chloride. Okay, we have the copper. Now we're gonna test this copper with 6 molar NH3. So we're gonna pour that into here until the solution is a basic solution. When it's basic, the solution changes color from a light blue to a dark blue. So right now the copper is light blue. We pour in the NH3, and there will be a color change to a dark blue color. So copper becomes dark blue. That means that there's copper ions in the supernatant. So when this turns dark blue, it means we have copper ions. Now the equations, looking off of the study guide sheet. Hold up, y'all. Hold up, y'all. Here we go. Looking off the study guide sheet. Okay, what reagent precipitates both Ag and Pb to isolate them from Cu? It's 6 molar HCl. It forms a white precipitate of Ag and Pb ions at the bottom and a light blue color of copper at the top. So now we're on what reagent can dissolve the PbCl2 but leave the AgCl solid. So we have the AgCl and PbCl2, and we want to separate those now. So what we do here is hold up. Give me a second, y'all. We're gonna separate the solids now. We're gonna add 8 drops of 1 molar sodium acetate. 1 molar of sodium acetate to this tube, which is left over. Cu has been removed. We're adding the sodium acetate to the precipitate, and we're stirring it, and then we're gonna centrifuge it, and then the silver ions are going to still be present, but the AgCl, the silver ions are still present as AgCl, but some of the lead ions have dissolved to form a complex. So this is what happens. You still have your silver ions down here, but up here you have your lead that has combined with the sodium acetate. So the lead is now PbC2H3O2, 4 2-, but the Ag is still AgCl. So now we've separated the two. We can either add some more acetate to separate it more. Now we want to add. Come on, y'all, give me a shout out. Preacher, say something. I need some help here. Remove the water bath, centrifuge it. Remove the thing from the centrifuge tube. Okay, yeah. Here we go. So we're gonna remove the Pb acetate from the centrifuge tube and put it in a test tube. So now we have a tube with just AgCl and a tube with Pb acetate. Now we're going to solubilize the AgCl solid. So this is solid here. So what we're going to do is add 6 drops of NH3, which we actually added up here to the copper one. So we added the NH3. And we're going to centrifuge it, remove the solution, supernate from each centrifuge tube, and the AgCl here should dissolve when you add NH3, giving a colorless solution because it forms NH3 and Ag+, so it's dissolved. Ag and Cl are separated now. Any white left over is likely the lead chloride that has not been dissolved. Now we're going to go to the test tube, right? We're going to go to the test tube that has Pb and then acetate, right? We want to know, is there lead in this solution? Testing for it. Now we know what's in this. This is known, but we're still going to run the test on it, because on the unknown we run a test too. So what we do here is we add 0.5 molar of acetic acid. Then we're going to add some drops of 0.1 molar of K2CrOH. And then the solution from the known ion solution should form a yellow. It should form yellow. And it should be PbCrO4 precipitate. What's that mean? It means the precipitate, the solid, is PbCrO4 now, and the acetate is now this on top, right? So when you have yellow down here, it means lead is in there. The color will be yellow for both positive and negative tests because the reagent is a clear yellow. So basically you need to test for the cloudiness of the test tube to see if there's precipitate formation and whether the lead CrO4 is formed. So basically, it's going to turn a clear yellow whether there is lead or not in here. But the more cloudy it is, if it's cloudy, then you do have lead. So you want to look for cloudiness, means there's lead in the solution. Now we need to test for the presence of Ag, the silver. What happened with the silver? Well, we put it we separated it from AgCl, right? And then the Ag was put into, well, we used the NH3 and separated it and put it in a test tube. So now what we're gonna do is take the silver and we're gonna add 5 drops of Ki, potassium iodide, and the solution should form a yellow silver iodide precipitate. So if it is yellow, it means there's Ag, there's silver in there. Again though, the cloudiness is needed, so if it's cloudy, and that means AgI has formed. So the Ki and the I and the AgI is formed. So if it's cloudy, there is silver in there. So that's all. Check out the next video for a breakdown of it all.